Let's clear something up immediately, because it changes how you should read everything else in this video. NASA didn't decode a hidden transmission from Voyager 2. There was no secret message, no code cracked open after years of concealment, and nothing remotely terrifying sitting in a vault waiting to be revealed. What actually happened is real. It's documented, it's been public for years, and it's genuinely stranger and more moving than the fabricated version of this story. This is the real story of what Voyager 2 actually sent back from the edge of the solar system, why turning it into sound wasn't decoding anything, and why the true version deserves your attention a lot more than a fake one ever could. Before we get into it, if you're new here, this channel covers space and astronomy stories the way working scientists actually talk about them, without the exaggeration. If that sounds like your kind of channel, the subscribe button is right there, and it genuinely helps this content reach more people who care about getting the science right. Here's where this actually starts. Voyager 2 launched on August 20th, 1977, 16 days before its twin, Voyager 1. Its original mission was modest on paper: fly past Jupiter and Saturn, gather data, and eventually become space junk once the fuel and the science ran out. Nobody, not even the engineers who built it, seriously expected it to still be transmitting, still making genuine discoveries nearly 50 years later. A rare planetary alignment, one that happens roughly once every 176 years, let a single spacecraft use the gravity of each outer planet to slingshot toward the next. And Voyager 2 remains the only spacecraft in history to have used that alignment to visit all 4 outer planets: Jupiter in 1979, Saturn in 1981, then Uranus in 1986, and Neptune in 1989, worlds no spacecraft had ever approached before or has approached since. At Uranus, it found 11 new moons and 2 new rings nobody on Earth had ever seen. At Neptune, it discovered the Great Dark Spot, a storm system the size of Earth itself, and confirmed for the first time that Neptune had its own faint ring system. That Neptune flyby in 1989 was the last time either Voyager's cameras were ever used. After that planetary tour finished, Mission Control did something almost nobody expected. Instead of shutting the spacecraft down, they aimed it outward toward the edge of everything the sun controls and kept listening. That decision is what eventually produced the real story behind this video's title. It's worth understanding one more thing both spacecraft carry, because it matters for how you should think about everything that follows. Bolted to the outside of each Voyager is a gold-plated copper phonograph record, curated by a committee led by astronomer Carl Sagan. Etched into it are 90 minutes of music from cultures across the planet, spoken greetings in 55 different human languages, natural sounds of Earth like thunder, wind, and whale song, and more than 100 images encoded directly into the grooves. At the time it was assembled in 1977, it was arguably more a piece of hope than science. A message in a bottle thrown into an ocean so large the odds of it ever being found by anyone are effectively zero. It's still out there right now, riding along with the exact same spacecraft producing the data this video is actually about. Now, the boundary itself. The sun isn't just a light in the sky, it's the center of an enormous invisible bubble called the heliosphere, inflated outward by the constant stream of charged particles known as the solar wind. Everything inside that bubble exists inside the sun's direct influence. Outside it is something completely different, the true space between stars, filled with leftover plasma, radiation, and magnetic fields from other stars that lived and died long before our solar system even formed. For decades, scientists assumed the edge of that bubble would be a slow, blurry fade, one environment gradually thinning into the next over a huge stretch of distance. Voyager 1 proved that assumption wrong first, crossing that boundary in August 2012 at a distance of about 121 astronomical units, roughly 11.3 billion miles from the sun, becoming the first human-made object to leave the solar system entirely. On the other side, the readings changed almost instantly. Solar wind particles collapsed, cosmic rays from deep space surged dramatically, and magnetic field readings shifted direction. That left one question hanging over the entire mission. Was that a fluke of Voyager 1's particular path through space, or a real physical boundary any spacecraft would hit in roughly the same way? The only way to know for certain was to wait for Voyager 2 to reach the same frontier from a completely different angle. On November 5th, 2018, it did, crossing the heliopause at a distance of about 119.7 astronomical units, just over 11 billion miles out, a journey that had taken 41 years since its 1977 launch. Almost immediately, its instruments confirmed what Voyager 1 had shown 6 years earlier. This wasn't a coincidence. It was a real physical edge to our solar system. And now 2 independent spacecraft, approaching from different directions years apart, had both measured it. 5 separate scientific papers analyzing Voyager 2's crossing were published together in November 2019 in the journal Nature Astronomy, each focused on a different instrument still running on the aging spacecraft. One of those instruments is where this story gets genuinely interesting. and it's the one responsible for the sound at the center of this whole video. It's called the plasma wave instrument, and its job is to detect oscillations in the ionized gas or plasma filling the space around the spacecraft. Here's the part that surprises most people. There is no sound in space. It's a vacuum, no air, no medium for a sound wave to travel through the way it does on Earth. What the plasma wave instrument actually detects is electrons oscillating back and forth, creating an electrostatic wave, a completely different physical phenomenon from the pressure waves that create sound in our atmosphere. But by pure coincidence, the frequency of those oscillations happens to fall within the same range the human ear can process, roughly a few hundred to a few thousand hertz. Which means if you take that raw electron data and run it through a loudspeaker, you can genuinely listen to it. Not metaphorically, literally hear it. Don Gurnett, the physicist who led the plasma wave investigation on both Voyager spacecraft for the University of Iowa, described exactly what that meant the first time Voyager 1's version played at a NASA press conference back in 2013. In his own words, it was a historic event, the first time humanity had ever made a recording of sounds occurring in interstellar space. When Voyager 1 was still inside the heliosphere, those tones sat low, around 300 hertz, consistent with the thin, hot plasma of the solar wind. The moment it crossed into interstellar space, the pit jumped sharply higher into the 2 to 3 kilohertz range, the unmistakable signature of colder, denser interstellar plasma pressing in around the spacecraft. That single measurable change in pitch was, on its own, hard scientific evidence of the crossing, independent of any other instrument on board. Voyager 2's plasma wave instrument, when its own data finally reached Earth years later, told essentially the same story from the opposite side of the solar system. Scientists measured a jump in electron density by a factor of roughly 20, almost the exact same signature Voyager 1 had produced years earlier at a completely different location, confirming beyond a reasonable doubt that both spacecraft had passed through the same kind of real physical boundary. Gurnett, reflecting on what the Voyager 2 data confirmed, put it plainly, the old assumption that the solar wind simply fades away gradually the farther you travel from the sun turned out to be false. There's a real, distinct boundary out there, sharper and more defined than most scientists had expected going in, something closer to a weather front than a slow fade, crossed by both spacecraft in a matter of days rather than the years of gradual transition earlier models had predicted. There was a genuine surprise buried inside Voyager 2's numbers too, where Voyager 1 had found the plasma just outside the heliosphere, slightly denser than predicted. Voyager 2 found it slightly warmer than expected, a subtle difference suggesting the sun's bubble might be compressing the surrounding interstellar material unevenly, shaped by the sun's own motion through the galaxy over millions of years. Now here's the part that actually matters most for understanding why the word decoded in this video's title is flatly wrong. The plasma wave instrument doesn't produce an audio file on its own. It measures the electric field around the spacecraft dozens of times per second and beams that raw numerical data back to Earth as radio. Telemetry, the exact same way every other instrument on the spacecraft does. That signal has to survive an 11 billion mile journey, arriving so faint it borders on theoretical, caught by giant dish complexes in NASA's Deep Space Network, spread across California, Spain, and Australia specifically, so that as Earth rotates, one of them is always facing wherever Voyager 2 happens to be, transmitting from. Scientists on the ground then take those raw electric field measurements and run them through a straightforward mathematical conversion, mapping the recorded frequencies directly onto an audible range and playing them through a standard speaker, without adding, removing, or altering anything about the underlying signal. Bill Kurth, a longtime member of the plasma wave team working alongside Gurnett, has explained the reasoning simply. Making the data audible isn't about spectacle. It's genuinely one of the fastest ways for a trained ear to notice a change in frequency or pattern that might otherwise take much longer to spot scrolling through a spreadsheet of raw numbers. In other words, the sound isn't decoration layered on top of the science, and it definitely isn't a code that had to be cracked. The name scientists willing to put their reasoning on the record is fully documented and publicly available, and has been for years. Compare that to how an actual fabricated space story usually spreads. It leans on vague sourcing, a no-name researcher willing to be quoted without ever being identified, and claims that get more dramatic the further they travel from the original data rather than less. As for where Voyager 2 actually stands right now, it's nearly 13 billion miles from Earth. Still transmitting, running on a radioisotope power supply that loses a little more output every single year, as the plutonium inside it steadily decays. Engineers have had to make increasingly difficult choices about which instruments to keep running as that power margin shrinks. Just recently, mission engineers pulled off a clever power-saving maneuver, informally nicknamed the Big Bang, expected to buy Voyager 2's remaining active instruments at least another year of operation before anything else has to be switched off for good. NASA's current projection is that the plutonium generators will likely fail sometime in the early 2030s, though the agency has been careful to note that estimate could shift, since the spacecraft has already blown past every original prediction anyone ever made about it by decades. When that day finally comes, there won't be a dramatic final message, no last transmission decoded in a control room somewhere. The signal will simply gradually weaken past the point where even the most sensitive receiving dishes on Earth can pull it out of the background noise, and Voyager 2 will fall permanently silent, continuing to drift through the galaxy on its own, carrying its golden record of Earth sounds and images to no one for longer than our sun has left to live. If you've stuck around this long, you already know this isn't the kind of story with a hidden code buried inside it, and I'd rather tell it straight than invent one. What's genuinely true here is a 50-year-old machine, built before most of the people watching this were born, still out there right now, past the edge of everything the sun touches, sending back the literal sound of the space between stars on a dying battery, with a team of scientists on Earth checking every faint signal that arrives, fully aware that any one of them could be among the last things this spacecraft ever tells us. If this kind of deep dive into real, sourced space science is what you come here for, subscribing helps a lot. Let me know in the comments what you think Voyager 2's instruments might still discover. Before the power finally runs out for good, it genuinely shapes what we cover next. And sharing this with someone who'd get a kick out of it is the easiest way to support the channel.